great day, parents and scholars. We'll continue working with fractions, and we are using the redraw right process. In other words, we are writing down, we're drawing out what we need to do next in the problem, okay? Rather than just writing numbers, there's always a basis where they can always use a tape diagram, which is at most times the most easiest way for them to figure out what the least amount of mistakes being made with them. So first we're looking at number 1. And these are very close to some of the examples they may have for homework. It says, Sheehan walks 1/5 mile in the morning and 3/5 miles in the afternoon. How many total miles does Sheehan walk? So the first process of read, draw, and write, of course, is read. The second one is to draw. What do we know? What have we gathered? So we know there are 2 different times that Sheehan walked. One was in the morning, and I'm going to put an M for morning and an A for afternoon. Okay? In the morning it said that she jogged 1/5 mile. So I'm going to do my tape diagram, and I'm going to show 1/5 by doing 4 partitions. 1, 2, 3, 4, and that gave me 5 pieces. And to show 1/5, I'm just going to shade 1. So this is what Sheehan's morning should look like. 1/5, I did 4 partitions that gave me 1, 2, 3, 4, 5 pieces, and I shaded 1. So this is 1/5. The afternoon, she walks 3/5. So the same amount. The idea that the tape diagram should be the exact same, because both of them are fifths, my denominator. I'm doing my 4 partitions that give me 5 parts, and I'm going to shade in 3, because she did 3/5 in the afternoon. How many total miles does Sheehan walk? Okay, so here we're looking for the total, and we're going to put a variable. This lets us know this is what we need to figure out. So I put the a lowercase a, that's unknown, or they can put the first letter in their first name. Okay, so I'm just going to add it up. 1/5, 2/5, 3/5, 4/5. So my answer is 4/5. That was the total number of miles that Sheehan walked. Okay, and they have to draw. Some may try to do this. 1/5 plus 3/5 equals 4/5. But we're really focusing now on the read, draw, write process. So this is what I'm looking for, the tape diagram. I'm looking for the tape diagram model. Even if they label it 1/5, I still want that tape diagram. Okay? Now we're going to move on to number 2. A container has 9/10 liters of water. Casey pours out 2 liters. How many liters of water are left in the container? So what do I know? I know that the container has 9/10 liters of water. So that's the total amount of water. Okay? So I'm going to do this and 9/10. Okay? And so I'm going to do my 9 lines. My 8 lines, 9 lines to give me my 10 parts. 1, 2, try and get them as even possible. 3, 4, 5, 6, 7, 8, and 9. Almost not quite even. And so I did 9 partitions, so that gave me 10 parts. Okay? So her container holds 9/10. So I'm going to shade in 9. Real quick and light. Remember, this is not art class, it's quick and light. 9/10. Okay? And Casey pours out 2/10. Okay? So I'm going to X this out. She poured this out. That's 1/10. 2/10. How many liters of water are left in the container? 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10. So I'm going to put 7/10 liters was left in the container. Okay? And there you go. So now I'm going to another one. Let's go to number 3 here, about a loaf of bread that Luke has. Luke bakes a loaf of banana bread. After giving some away to a friend, he has 5/6 of a loaf left. How much of a loaf does Luke give away? So the first thing I'm going to do is I'm going to do my loaf. So how much would a full loaf? How much is a full loaf with just the slices? I know that because the denominator is 6. So that means in the entire loaf there should be 6 slices. Therefore I'm going to do 5 partitions to give me 6 slices. 1, 2, 3, 4, 5. So they gave me 6 slices. Not quite as even as I needed it to be, but that's fine. So I'm going to say this is my 1 whole. And I know my 1 whole is 6/6. Okay. Now it says, after giving some away to a friend, he has 5/6 left. Okay. So let me shade, but I have to make sure when I shade is what's left. Okay. So 1 6, 2 6, 3 6, 4 6, 5 6. And I want to label this. This is what he gave. I'm sorry. This is what he has left. So I'm going to put leftover. Okay, so then it says, how much loaf does Luke give? Well, how much is left? This right here is what he gave. The leftover was 5/6. This is how much he gave, which is 1/6. So we will put Luke gave away 1/6 of a loaf or the loaf. Okay, so you have to make sure that 5/6 says what was left. So I marked the 5/6 out and I labeled this is what's left over. And okay, so now what's left? How much did he give? He only gave 1/6. Okay, and then I wrote my sentence, the W in the read, draw, write process. Okay, now we're going to look at what Miss Diaz has done here. It says Miss Diaz buys 7/8 pounds of strawberries. She also buys 5/8 pounds of blueberries and 3/8 pounds of raspberries. And A says, how many pounds of berries does Miss Diaz buy? Okay, so I read it. Now I'm getting ready to draw out what I know. I'm going to put my S for strawberries, my B for blueberries, and my R for raspberry. And 7/8, I'm going to draw that out. Let me go ahead and do one big tape diagram and then portion it out. So 7/8 was the strawberries, 5/8 was the blueberries, and 3/8 were the raspberry. Okay, so I need to do 7 partitions to get the 8 pieces, which is our denominator. So I'm going to do 1, 2, 3, 4, 5, 6, and 7. So 7/8, so I know I'm shading all but 1. That was my strawberries. My raspberry, 1, 2, 3. My blueberries, 1, 2, 3, 4, 5. And my raspberry, 3/8. 1, 2, 3. And the question says, how many pounds of berries does Miss Diaz buy? Okay. So we have 7/8 here. And I could move this 1/8 over here. And that'll give me my 8/8. Because it's just 1 here, so I transfer that over here. Now I have 1, 2, 3, 4, 5, 6, 7, 7/8 left, and that gives me 1 pound and 7/8. Okay, and 7/8 ounces. Okay, or another way a student may see this, they may choose to do 7/8 plus 5/8 plus 3/8, and that'll be 10 plus 5, that'll be 15 over 8, because remember the denominator stays the same. We do not add or subtract the denominators. And this is called a fraction greater than 1, because the numerator is bigger than the denominator. We are not allowed to leave it like that. So we're going to take our whole piece out of the 8. So we're going to take 8/8, that equals 1 whole. Can we do another 8/8? No, because if we do, we'll have 16/8, and we cannot pass the 15/8 that we have. So we can do 7/8, so plus 7/8, and you'll still end up with the same thing, 1 and 7/8. Or some of my friends may choose to do the tape diagram, which I always think is easier to draw it out. You can see it plain. So I would do me a tape diagram. And with the tape diagram, we have the total right here of 15/8. So once you get your fraction that's greater than 1, because you easily could do 15/8 here, but I saw 8/8, I know that's 1 whole. That's why I reference as 1 whole and then 7/8. So 15/8, I'm going to do 14 partitions here. So I have 15 total pieces. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay? And 8 is my denominator, so 8 pieces make up my 1 whole. So I'm going to do 1, 2, 3, 4, 5, 6, 7, and 8. That's 1 whole piece. And then I have 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8. And you can get 1 and 7/8 that way. Okay, so the nugget that I want to give is easier to me, I think, for kids to see when they're drawing out that tape diagram, because it says it for you. It leaves out any error of making a mistake in the addition part or in the converting part from a fraction greater than 1 to a mixed number. Okay, because it lays it out. You identify your whole piece with 8 in there, you have 1 whole, and then you have your 7/8. Okay, see you tomorrow.